Hello, my dear grade 9 learners. Welcome to our second video lesson. By the way, are you done watching the first video about angles of elevation and depression? If you haven't watched it yet, make sure to watch it first before this video. Once again, I am Teacher Bless and I'll be your teacher for this second video lesson on problems of angles of elevation and depression. Are you ready? Let's go! Let's begin with our lesson objectives, and these are the following. First, solve real-life problems involving angles of elevation and depression. Second, listen attentively to this contextualized recorded video lecture with enthusiasm for you to understand your lesson better. But before we are going to proceed with problem solving, let's have first a short review on some of the lessons that you've learned in your module number 1. I have here this triangle. How do you call this triangle? All right, this triangle is what we called a right triangle. As you can see here, we have one angle that measures 90 degrees, and that is your angle C. Let's name this triangle as triangle ACB. We have three angles, and these are your angles A, C, and B. And of course, we have also three sides, and these are A, B, and C respectively. Now try to observe your three sides. Which of them is the longest? All right, that would be your side C, this side here. How do you call the longest side in a right triangle? This is what we call your hypotenuse. How about the two other shorter sides, which are your sides A and B? These are called your legs. Now, this is what you're going to remember. In a right triangle, the longest side is always your hypotenuse, while the two remaining shorter sides could be your adjacent or opposite side depending upon your angle of reference. Let's consider this illustration. I have right triangle A, B, C with angle C, the right angle. What side is your hypotenuse and what side are the legs? You're right. Side C is your hypotenuse while sides A and B are the legs. Now, there are instances that you will be asked to determine which one is your hypotenuse, your opposite side, and your adjacent side. Now, it would be easier for you to identify the hypotenuse because it is the longest side and it's the side opposite to your right angle. So in this illustration, what is your hypotenuse? That is your side C. So you have here C as your hypotenuse. Now for your opposite and adjacent sides, these depend upon your angle of reference. Now when we say angle of reference, it could be any of the acute angles in our given right triangle. So it could be A or it could be B. Now suppose that we pick angle A as our angle of reference. What is your opposite side and what is your adjacent side? Try to consider angle A. Now when we say opposite side, that is the side that comes across the angle of reference. So in this case, that is your opposite side. Okay? Atbang in short. So that is your side A. Now, when we say adjacent side, that is the side next to your angle. Now, take note, this is our angle of reference. The side next to your angle can be C or B. Take note, C is our hypotenuse. Therefore, B here is our adjacent side. All right, let's have another example. How about if I'm gonna change my angle of reference to angle B? Try to consider this angle. Does your hypotenuse change? It's not. It's still the side C. So you have here, hypotenuse is C. How about your opposite side? And how about your adjacent? Try to consider this arrow. So your opposite side changes. And this is now your side B. And your adjacent side, this is now your side A. So as you can see here, your opposite side and your adjacent side depend upon your angle of reference. Now, another lesson discussed in module number 1 is the primary trigonometric ratios. Can you still remember what are those? All right. So we have here the first one, sine ratio. Second, cosine ratio. Thirdly, the tangent ratio. Now, when can you use the sine ratio? How about the cosine ratio? And how about the tangent ratio? So remember, when we say sine ratio, that is given by opposite over your hypotenuse side. While when we say cosine ratio, that is adjacent over your hypotenuse. And lastly, when we say tangent ratio, that is opposite over your adjacent side. So we have here our technique in memorizing this primary trigonometric ratios. We have here SOHCAHTOA. You have here sine opposite over hypotenuse, cosine adjacent over hypotenuse, and you have here tangent opposite over your adjacent. Finally, before we proceed with problem solving, let's have first our calculator check and setting up. So I want you to get your calculator and let's set up it together. Are you ready? Let's go! So I hope you have now your scientific calculator and let's set it up together into the degree mode. So I have here my scientific calculator. So the first thing we're going to do is of course to turn it on. So click on, and then after that, we're going to press shift and then you go to mode or setup. Click it once. And then this appears in your screen. Now for us to set it into the degree mode, we are just going to look for the word deg. And that is number 3 in my screen. So what I'm going to do, I'm going to click the number 3. Here you go. So your calculator is now in the degree mode. And you are now good to go. So let's have problems involving angles of elevation and depression. Let's have the first problem. A tree in your school's gulayan that measures 12 meters is 14 meters away from a certain rock in the ground. What is the angle of elevation of the rock to the top of the tree? All right, so if you're given with a word problem, the first thing that you're going to do is, of course, to read and understand the problem. After that, you are now going to identify what are the given condition or conditions and what you're looking for. So let's identify the given condition or conditions. So you have here, the first one is you have 12 meters. And accordingly, that is your height of the tree. Next, we have also 14 m, and that is the distance between the rock and the base of the tree. And unknown. So what are we looking for? We have this question. What is the angle of elevation of the rock to the top of the tree? So we are looking for the angle of elevation measurement. So let's now have our illustration for us to visualize the situation. So suppose that this is your tree on your gulayan ng paaralan. So accordingly, the height of the tree, that is 12 meters. And there is this rock that is away from the base of the tree. So suppose that this is the rock here. And we know, based on the condition, the distance from the rock to the base of the tree, that is 14 meters. And we are asked to find the angle of elevation from this rock to the top of the tree. So this angle here. As you can see, we have a right angle or right triangle that is formed. So you have here this missing angle. So suppose that we let this angle to be theta. Now, if we let this angle here to be our angle of reference, what is 12 m and what is 14 m as the side of your right triangle? Okay, that is your opposite side for 12 m, and we have 14 m as our adjacent side. Opposite and adjacent. Therefore, what ratio is applicable based on the review that we had earlier? That is your, okay, tangent ratio. So you have here our solution. So we have tangent ratio, opposite over adjacent. So here we're looking for theta, so we can simply copy tangent of theta, and then we replace our opposite and adjacent values. So opposite, that's 12. So you have here 12 m over the adjacent, that is 14 m. So m and m here in your numerator and denominator will be canceled out. So you have here 12 over 14. Now, as you can see here, we're looking for an angle. And this is the rule that you're going to remember. You have to shift your calculator. So kindly get your scientific calculator and let's input this one together. So you have here, press on, and then let's do this one together. So you have shift, and then the ratio is tangent. So you have tan, and then you input 12 over 14. Don't forget to close. And then you click equal. So you have here 40.6 and something. So your theta here is equal to 40.6 and something. So for uniformity purposes, I want you to round this off to the nearest whole number. So since this is 6 here, so you have to round it up. So 6, so this is going to be 1 here. So you have here, theta is approximately 41 degrees, and that is our angle of elevation. So you have here your conclusion. Thus, the angle of elevation from this rock to the top of the tree, that is 41 degrees. Let's consider our second example. A flagpole stands 6 meters tall from the ground. Find the angle of depression if the distance from the top of the flagpole to the tip of the shadow is 11 meters. So as what we did in our example number 1, we need to identify first what is or are the given condition or conditions, followed by what we're looking for or known as your unknown. So here, let's identify first the given condition or conditions. You have here the first one. You have a flagpole, and accordingly, that is 6 meters tall. And we have here the distance between the top of the flagpole and the tip of the shadow. That is given by 11 meters. Now, what are we looking for? Try to consider our problem. You have this one. Find the angle of depression. So we're looking for the angle of depression. So this time, let us now illustrate our situation for us to visualize what we're looking for and what are the given conditions. So suppose that this is your flagpole. So accordingly, based on our problem, we have here the height of the flagpole, that is 6 meters. Now in our problem, we're given with the condition that there is a shadow. But take note, we are not given with any measurement. So suppose that this is your shadow. And the last condition, you're given with the distance from the tip of the shadow to the top of your flagpole, that is equal to 11 meters. Now, what are we looking for? We are asked to find once again the angle of depression. So where is your angle of depression? Take note, if we are going to consider our illustration, at the top here of your flagpole, we have this horizontal line. And when we say angle of depression, that is this angle here. From this horizontal to this line of sight. So this angle here is the angle that we're looking for. Now suppose that we represent that angle to be our angle theta. Now, what's the relationship exist between this angle here and this angle here? Try to recall your video 1 lesson. All right, these two angles here are congruent. Okay, this angle here, the angle of depression, and this angle here, which is your angle of elevation, they are congruent. As you can see here, we have two parallel lines. This horizontal line here of your flagpole and your ground here, which is represented by your shadow. Now take note, these two parallel lines are cut by this transversal, which is your line of sight. Take note that their relationship, they are congruent. Okay, so since this is theta here, this is also equal to theta. Now, if we let this angle here to be our angle of reference, what side is 6M and what side is 11M? As you can see here, we are able to form a right triangle. Okay, so this one is your opposite, while 11M is your hypotenuse. So what ratio now is applicable? Take note, opposite and hypotenuse. That is your, okay, sine ratio. So you have here your solution. Sine theta is equal to opposite over your hypotenuse. So since we represent this with theta, so you have here sine of theta, and then we replace opposite and hypotenuse based on our given measurement. So opposite, that is 6m, over hypotenuse, that is 11m. So once again, we can cancel out m and m. So you have here 6 over 11. So once again, since we're looking for the angle, what to do with our calculator? You have to shift. Okay, so kindly get once again your calculator and let's input this one all together. Okay, so you have here shift, and then you have sine because you have here sine ratio. Sine, and then you have here 6 over 11. So you have 6 over 11. So you have here, you click your equal sign. So that is 33.05. You have here, theta is equal to 33.05. So once again, let's round it off to the nearest whole number for us to have a uniform answer. So since this is 0 here, and then you have 5 here, round it off to a whole number. So 0, that's gonna be round down. So that would be 33 degrees. So since this is 33 degrees here, therefore this is also 33 degrees because we know that they are congruent. So you have here your conclusion. Thus, the angle of depression is approximately 33 degrees. Alright, that's it for problems involving angles of elevation and depression. I hope you've learned from this video. Feel free to play, replay, or even pause for you to understand your lesson better and for you to answer your modules correctly. See you on our next video for module number 5 and have a great day ahead. Bye-bye!